Hello the internet and welcome back to Tony359's second channel. Now I've got on the bench here the power supply that I fixed on the main channel. You'll see the link here down below in the description. And it was working. I was testing it in the device it belongs to, and I think I noticed something weird. As you know, the 5 volts and the 15 volts of this power supply is adjustable, so I adjusted the 5 volts to something like 5.0 something, you know, just above 5 volts. And I let it run for a few hours. I think I came back like after a day or so, something like that. And I found it at like 4.9 some volts, which is, you know, it's not the end of the world, but it's a medical grade power supply. It's regulated. The regulation happens with the remote signal at the motherboard. I was not expecting that drop. And I thought, well, maybe I just forgot. Maybe I just didn't set it to 5 point something. So I set it back to 5 point whatever it was. And I came back after a few hours and it was back to 4.9. So I started looking into that and I noticed that once I was setting the voltage to 5 point some volts, the voltage at the test points of the device it was connected to, it was very, very slowly decreasing. Like the second decimal digit was going down like 1 every 30 seconds. So it was like 5 point... it wasn't the second one, it was the third one. 5.087, then it was 5.086, 5.085, and so on. So obviously after many, many hours, it was managing to going down to 4.9, and I thought, is this supposed to happen? I can't remember seeing that. Now, I have a number of these power supplies, I have a number of the devices where these power supplies live. So I started, checking, comparing things, and no, I couldn't see that change at all. You know, once I was setting the voltage, it was completely stable, as you would expect, to be honest. I mean, it's supposed to be a very high quality power supply. So I started looking into that, and I think this power supply is not completely fixed. And I thought, I don't want to make a main channel video. We talked about this power supply already. That was enough. I thought I'll just do a follow-up on the second channel. That's why I have a second channel. So from my understanding, the 5 volts is the main voltage which is driving the switch and controller. And the 15 volts, I think, is it gets what comes from the switching transformer, and then he has his own regulation on the secondary. So whatever happens on the 15 volts doesn't really affect the duty cycle of the controller. That's my understanding. I'm not entirely sure. I haven't got schematics. Schematics are not available for this power supply. I was looking at the generic schematic of this controller. It's very useful because you would expect a regular power supply to just follow the schematics. Maybe not 100%, but maybe like a good 80-90%. So here on the right hand side is where the regulation of the 5 volts happens. There is a TL431, which is always involved into a feedback circuit. There's a small capacitor. The one with the green dot is the one that I replaced, and the reason is it tends to fail on these power supplies, so I tend to replace it as a preventive maintenance. And then the signal from here, which is going through the potentiometer here, which is allows me to regulate the actual output, goes to the optocoupler, which is then feed the signal back to the main controller, and the main controller then changes the duty cycle to compensate for that. Now, when you're diagnosing a feedback circuit on a power supply, it's complicated because if you see a change on the feedback, it means that something's happened, but you don't know where that happened, because the change in the feedback will also go to the controller. The controller will react to counteract it, I guess, and that means that your feedback is also changing, which is also going to the controller, which is changing, which is going to the output, which is going back to the feedback, and so on. If you know what I'm saying, it's like the chicken and the egg. You don't know which happens first. Anything that changes on this whole loop will affect everything instantly. So I'm assuming that with like a very good oscilloscope, multiple channels, you can probably see which happens first. But I don't think I want to go that direction. So I would say, first of all, let me show you what happens, what I found. And then I have a good power supply. We can do some comparisons. And hopefully, we can find out whether we can fix this. Because I'm not really happy to have this power supply, just changing voltages randomly like that. It doesn't feel right. So right now, I got the Fluke connected to the 5 volts. And I have my little load here on the right hand side, which is connected to all the voltages. So, all are being used, not too much. I don't think it's more than maybe a couple of amps for the 5 volts, but it's totally fine. And I'm going to show you what happens. So let me power on this thing and we get 5.276. Fine, I'm totally fine with that, whatever voltage that is. 5.276, and it is stable, even though I guess if you look at the last digit, 5, now it's 4, and it will probably become 3 in a moment. It's 3 now. You see what I'm saying? Even it's here doing nothing, and that's slowly decreasing, and it feels like that's really not a problem. But over 24 hours or more, it will drop quite a lot. Now, you know what's my favorite diagnostic tool here in my workshop? Hot air and cold spray. Now, obviously, this feels like a temperature problem. Something is warming up and is changing its characteristics too much. So 69, look at that. So what I'm going to do, I have my hot air station here, which is set at 290 degrees, but it's very, very low airflow. I can barely feel it, but if I keep it steady, I will burn my hand. And I'm going to warm up the feedback area in there. Let's see, keep an eye on the voltage and see what happens. So 5.265. There you go. 5.25, 24, 23, 22, 21. That shouldn't happen. Okay. That's not normal. And actually, how do I know that that's not supposed to happen? Because if you think about it, it's not too much. I'm warming up a component really hard. Maybe that's supposed to happen. So I had this doubt, and I decided to go ahead and get another power supply. It's fully working. I don't think I've ever touched this, so I think this is factory, and we can do a quick test. So I'll switch this off, remove mains, remove my load here, and I'm going to just plug this up exactly the same way, so same load, and I turn it on now. We got 5.19. Let's give it a few seconds to stabilize. Perfect. 5.19 something, and I'll warm up the same area here. And as you can see, nothing happens. Absolutely nothing. 91, 92, 93. I don't care about that. But it didn't go down to 5.0 something. The other one clearly has a problem with the feedback. Now, what is that? What is the problem? So I am back to the faulty power supply, and I'm trying to probe the TL431, which is an adjustable reference voltage, and that's a pretty common component that you find in the feedback of a power supply. Now, if I understand correctly, the TL431, depending on some resistors connected to it, will output a reference voltage which is fixed. It doesn't change, and I guess it depends on the resistors that you are connecting to it. So one thing that I'm wondering is, when I warm up the area, is the reference voltage changing? Because that might indicate that the 431 is faulty. So I've got everything plugged back, including the load. I've got mains coming in. So let's turn it on. 3, 2, 1, go. And I should read, okay, I've got a 2.37 reference voltage, which is set. And I don't think this changes with my potentiometer here. So I'm trying to adjust the 5 volts. It does change a little bit. Yes, 2.37 and 2.39. But anyways, let's leave it to a random 2.385. And let's warm up this area and see if that changes. Okay, I'm warming up now, 386. And it doesn't change. It doesn't change whatsoever. I'm warming up the 431 directly. It has changed a bit. So is that enough for the output voltage to change so dramatically? I don't know. The next step is to check that capacitor that I actually have replaced. Now the thing is, I can't remember where I got those capacitors. Chances are they're coming from eBay. So, it's never a good idea. I tend not to buy components from eBay for something I care about, let's put it that way. But I can't remember. They've been there for quite some time. Is that a tantalum capacitor? It is. I have another one of these capacitors here, which are from the same little plastic bag I have. And I want to test with my Fluke multimeter whether it's on the floor now. I want to check with my Fluke multimeter whether the capacitance is changing a lot with hot air. So it's now reading 1.073. And again, multimeters are, I don't know, even the Fluke is not great at measuring these things. But let's try this, 1.075, and I'll warm up this little capacitor here. So it went from 1.07 to 1.2. It's a capacitor. I honestly think that capacitor has it's not like 1% or anything. I think it's still 20%. So it's probably within parameters. I'm wondering whether either I'm using the wrong component, maybe it had a tighter tolerance, though I don't really know. So maybe we can try and swap this one. But another test I'd like to do, and I'm going back to monitoring the 5 volts out of this power supply. Okay, I got 4.85. Well, that's a random voltage. I'm going to warm up that capacitor, and I'll try to be as careful as possible. Obviously, when you're warming up and cooling down, it's easy to warm up and cool down adjacent components, and see whether that is my problem. Well, at least I'll try. So let me try now. So 4.85. Or 4.82. It didn't drop too much, but it's definitely dropping quite a lot. You wouldn't expect that kind of drop on such a good quality power supply. And then hopefully, this is massive thermal shocks, but it's definitely going back up. And I'll try and cool down only that capacitor, which is going to be challenging. Maybe not. The thing is, it's definitely something in the area. And I'm not entirely sure what happens if I warm up if I warm up the 431, it also goes down in voltage. Hopefully you can see that. 4.81. And if I now cool it down, yeah, I can see something there as well. Unless it's that little adjacent capacitor, the blue one. It's impossible with hot air and cold spray to just be so precise. So I would say let's start replacing those components, because I think I have a replacement for all of them, assuming that little blue one is a 104, like the one that we had on this very power supply. I have replacements. I would say let's start replacing those 3, and I think I will. Shall I start again from the one that I actually replaced, that little tantalum capacitor? I'll just use another one and see if that changes anything. I'll do one at a time because I'm curious to see which one is the problem. Let me start with that tantalum. I'll just put another one on, and then we'll try again. If that doesn't fix, we'll move on. It's a little bit of a pain because disassembling this thing takes a little bit of time, and I don't really want to turn it on without the cage, which is the heatsink. In case, by the way, that is affecting the test. Let me start replacing the little capacitor here, see if it makes any difference whatsoever. I got carried away when I explained the feedback circuit, so let me clarify how it works real quick. It's pretty easy and fascinating. The main controller on the primary section drives the MOSFETs, which chop the DC voltage going to the main transformer, which then gets rectified and stabilized into the output voltage, which is 5 volts on this power supply. The feedback circuit is in charge of monitoring that 5 volts and feed it back to the main controller IC in case it changes. In order to do so, a TL431 and an optocoupler are used. The TL431 generates a fixed voltage of 2.495 volts internally. The 5 volts output is reduced to 2.495 volts via a voltage divider and fed into the TL431, which now compares this input with its own internal reference voltage. The difference between the internal reference voltage and the voltage coming from the main output is called the error, and the role of the circuit is to minimize the error, which happens when the output is precisely 5 volts. The TL431 drives the optocoupler, which is just an LED shining light into a phototransistor on the other side, on the primary section. This is to ensure the primary and secondary sections remain electrically isolated. The phototransistor is connected to the feedback input of the main controller. When the power supply is turned on, there is no output, so there is no voltage reaching the TL431 from the output. The TL431 signals this situation by turning off the LED. As a consequence, the phototransistor remains inactive, telling the controller, "We need more voltage here." The controller reacts by quickly raising the output voltage. The voltage reaching the TL431 from the output also increases. This causes the LED to start shining light into the phototransistor, signaling the main controller that voltage is rising. At some point, the main output would have reached 5 volts, the voltage going into the TL431 would have reached 2.495 volts, bringing the error to 0. The LED has now reached enough brightness to tell the main controller IC, "We are good here, keep running at this pace." From that moment, the TL431 keeps comparing the voltage coming from the output with its internal reference voltage. If the output voltage, say, went over 5 volts, the TL431 would drive the LED a little bit brighter, telling the main IC, "You need to slow down." So under normal circumstances, it's normal to read 2.495 volts, or very close to that value, going into the TL431. Any other values would cause an immediate reaction, which would try to bring that value back to the TL431's internal reference voltage of 2.495 volts. I've got the little capacitor out, it's reading 1.10 microfarad, and if I warm it up, as before as the other one, it goes up to 120 something, so it doesn't change massively, dramatically. And if I cool it down, it goes down to 1.06. I would say similar to the other one. It's a bit higher, but I think that's totally fine. So I don't think that is a problem, but I want to start one component at a time. And you know that component testers are never telling you 100% of the story. So it could be that this is working with the tester, and then when it's in circuit for whatever reason, it misbehaves. So I'll replace this and we'll test again. Alright, power supply is back together with the new capacitor. So let's make sure we have an output first. 3, 2, 1, go. We do have an output, 4.8. Let me just take this up a little bit to 5 point something. 5.05, and yeah, it's not as stable as I'd like. It's not doing anything. But let's warm this up as before and see what happens. 5.05. No, 5.04, 03, 02. Okay, so the capacitor, well, I can't be 100% sure that it's not the problem. Maybe it's just the wrong type of a capacitor. So the next step, I'd like to check the blue capacitor. Let me check on another board I have here. Yes, it says 104, this one here. And I do have 104s. They're not blue. Hopefully that's not going to make a difference. I'd like to swap that one. We can measure it, of course. And if that is not the problem, then I should have some 431s. And I'll swap that one and see what happens. I know this is a little bit of a throwing components at the board, even though, again, I think I've isolated the area. I'm confident that it's something happening in here. And we'll see what happens. One thing, it could be one of these potentiometers that is reacting with heat, because obviously when I'm heating this area, I'm heating a little bit of everything. So I don't know, lots of question marks, but let's not overthink this too much. Let's go ahead and replace that small capacitor. Well, I was desoldering the capacitor and I noticed the leg just spun up like 360 degrees, and the capacitor is now cracked. Now, did I break it by desoldering it? But that would be the second broken capacitor on these very boards, so it's a bit concerning. And hopefully, that's our problem with this with this power supply. And when it comes to power supply, there's plenty of projects available online, and PCBWay has their own shared section on their own website. So wherever you find the project, whether it's on PCBWay.com or anywhere on the internet, all you need is the Gerber file, and then you can upload it on PCBWay.com. The process is more or less automatic. I tend to change the color of the PCB, as you can see here. Then you just choose a postal service. PCBWay will manufacture your PCBs and will deliver them at your place. If your project requires a 3D printed item or any metal sheet fabrication, well, PCBWay is your stop as well. They can help you with that as well. If you follow my channels, you know I've been using PCBWay for quite some time. I can definitely vouch on the quality of the PCBs, never had a problem, and customer service is always top notch. Take a look at PCBWay.com, the link is also down below in the description, and let me thank PCBWay for sponsoring my channels. Their help makes these videos possible, so thank you very much PCBWay. Now let's continue with this power supply. Right, capacitor is replaced, Fluke is on the 5 volts, let's power up and see if it works. 3, 2, 1, go. Yeah, we've got 5.08, just not jumping so far, which is, no, it is jumping. That's not good. It's still jumping a bit. Let's try with hot air again. Whoa, it's not changing. Maybe a little bit. It's much better than before. It is changing a bit. It is changing, but it's better than before. So does that mean it's fixed? I don't know. So with cold spray, I'm reaching 5.08, which is kind of unrealistic because obviously everything now it's white. 5.08, and if I'm warming it up slowly, so I don't shock the components too much. I mean, I'm going down a bit. I guess this is kind of an unrealistic test, obviously. I'm warming them up quite a lot. I'm going to 5.05. I'm guessing it would probably go a little bit lower if I keep warming it up. But it's nowhere near as it was before. And I don't know, from 4.06, from 0.08. Is that acceptable? I think the factory power supply doesn't even do that. So I'm wondering whether I'm using different capacitors, which are a bit more, have a little bit more tolerance, even though those capacitors, I think that just by construction of a certain tolerance, it's not like resistors. I don't know. It feels so much better though. I'm back on the factory working power supply, and I do see it's jumping a little bit as well. So maybe it's totally normal. I set it to 5.08 as the other one, and let's try and warm up this area. Yeah, I mean, it is going down a bit. I mean, when it gets really warm, I would say, it's going down a bit. I would say probably the other one is totally acceptable now. You know, 5.08, 5.07, the other one is going down a bit more, but it's definitely much better. So I'm assuming that capacitor, I might have broken it when I desoldered it, but it was probably cracked inside. And that's why it was reacting to hot air and cold spray. I think I'll have to test it a bit in its own device in a real world situation and testing there. And, you know, as long as I don't find the voltage down to 0.3, 0.4 volts the following morning, I think I'm fine with it. But what do you think about it? I think this is probably fine. I mean, more than that, I would say we could try and replace the 431 and those resistors, which I don't have. And those resistors are probably definitely like 1% tolerance. They're like high precision resistors, so I need to be careful with those. But I think I'm happy with that at the moment. It's definitely much better than it was before. Right, so I've tested this power supply for a few days, and I think it works-ish. What I mean with that is that I compared this to a known good power supply, and I found that, like, say after a couple of days, this power supply was dropping up to 48 millivolts compared to the initial voltage, while a good known power supply, I'm assuming is good, these are old stuff, was only dropping 10 millivolts. So I think it's fine. Again, this is nowhere near what it was before. I didn't really check the exact amount, but I do remember turning it off one night and it was reading 4.9, and the following morning when I turned it on, it was reading 5.4. So that's 500 millivolts of drop, and I could see that I couldn't really adjust the voltage anymore. I was at the end of the range. Nothing like that happens with this one. It only goes down 48 millivolts and then it does stabilize. So I think, it's an old power supply. It's 20, 25 years old. It's been used probably quite a lot. And I feel there's probably a combination of factors, lots of small components probably drifting a minor amount, and you end up with this little extra voltage drift, which is probably totally acceptable. So I think this is like totally fine, and I don't want to chase ghosts in further analyzing this thing. But you know me, and you know that the purpose of this channel is not just fixing the thing and move to the next one, it's also understanding. So before moving on and before deeming this power supply as completely fixed, I'd like to check one thing, which is the voltage input at the TL431. Now, earlier on in the video, we noticed that the voltage was not 2.495 as you'd expect. It was something weird, something different. So first of all, I want to check that this is now back to what it should be, 2.495. And if it is, it probably means, again, as I said, that probably going to be a combination of several components aging up a bit over time. It could be anything. And you end up with a minor voltage drop, which it could be totally normal for this type of power supplies. So I got the power supply connected to my load, and the Kaiwitz is measuring the 5 volts outputs. So if I'm trying and adjust the output, you should see the output changing between, I think it's like 4.5 and 5.5, something like that. While the Fluke is reading the input pin of the 431, TL431, of the feedback circuit. So we are expecting something very, very close to 2.495, potentially 2.495 exactly. So let's turn on the power supply in 3, 2, 1, go. Okay, we got 5.22 volts at the output and 2.492, which is so much better than it was before. I can't remember what it was, but it was nowhere near that. And let's see what happens when we change the voltage. So I'm on 5.2. If I'm going up to maximum, which is 5.5, that is not changing, which is great. And if I'm going down to minimum, it should be 4 point something. There it is, 4.48. That actually hasn't changed, so that behaves even better than the good power supply, where you could see the voltage of the 431 somehow changing at the very extreme of the range. This is not changing. I can go up and down, and it's completely stable. So that seems to be good. However, there is a little thing that apparently I can't show you now. Now, I did test this earlier on before shooting the video, and I was actually reading 2.490. And after a while I was tinkering with this, it actually went up to 492. This has been off for a few hours now, but it's still 2492. So I kind of feel that maybe there could be an issue with the reference voltage of the 431, because this should really read 2.495 and definitely not 2.490. And maybe this little variation that I'm seeing here, and unfortunately I can't show you when it was reading 2490, maybe that's the reason for the minor voltage drop that I've experienced when I was testing the power supply. So I don't mean to overthink this too much and to chase too many ghosts, but I'd like to chase at least one. Now, I happen to have a TL431 in my stash. I only have one, so I really would like to see if I replace it, do I get 2.492, and does that improve on that minor voltage drop that I'm seeing when I'm testing it? I don't know, I'm just curious. And so let's disassemble this again, replace the 431 and test again and see what happens. Okay, the 431 has been replaced. Let's turn it on and see if the input of the 431 itself reads any difference whatsoever. In 3, 2, 1, go. Oh, it's even worse. Right, 2.485. That's interesting. So what happens if I change the output from 5 volts to 5.5, 2485, and down to 486? It's more or less unchanged. Yeah, between 8.5 and 8.6 are the two ranges. That's interesting. Now, looking at the 431 datasheet, I can see that the voltage reference to the 431 itself can actually change depending on temperature. It's a very small change, of course, that's why the 431 is used for this kind of feedback signal, but it should really read 2.495 at 25 degrees. I have slightly less than 25 degrees in here right now, so I don't know, but I can see that at minimum temperature it can go down to 2.483. We are 2.486. So, I don't know, it kind of doesn't feel right, but as I said before, probably I'm chasing ghosts here. So I feel this is beyond my level of expertise and knowledge. But what I'd like to do now is to test again this power supply, because maybe, yes, it's now reading 2.486, but that's going to be more stable than before. So maybe I'm not going to read that 48 millivolts drop. So I'll put this back into the device it belongs to, test it for a couple of days, and I'll let you know the outcome. And now I've tested the power supply again, and it behaves as before. It drifts up to about 48 millivolts and then it stabilizes. Also, meanwhile, I've repaired another power supply, identical power supply, which happened to have exactly the same fault. The controller was damaged, and I tested it, and this one is drifting about 23 millivolts. So now we have a factory power supply which is drifting about 9-10 millivolts. The one that we repair on the video, which is 48 millivolts, and this one which is drifting 23 millivolts. So now I'm, beginning to think that this is totally normal, and like 50 millivolts. Yeah, it's kind of the highest of the lot, but probably still totally fine for this kind of power supplies. That being said, I had placed an order for some components already for the next stage, and they come from DigiKey, and don't want to say kind of expensive, but they're not massively cheap. The point is, I would like to, see if they make any difference whatsoever. These are 1% resistors, 1% tolerance resistors, so let's call them precision resistors, and they are parts of the feedback circuitry. I'll show you in a minute, but basically if those resistors drift with temperature or whatever, it's basically like someone is adjusting the voltage output from the trimmer itself, because that will change the feedback going back to the power supply. So that the effect of that would be that the voltage will change. So I want to replace those 4 resistors just in case, over time, over these 20 years, they've degraded a bit and now they're drifting a little bit in value, and that should affect the voltage output, and the power supply is only doing what the feedback is telling it to do. I've also ordered some TL431 replacements from DigiKey, because I think the one I used originally was from eBay, so who knows where it's coming from, because what puzzles me is that the voltage coming from the feedback circuitry, the voltage divider, is not exactly or very close to 2.495 volts, which should be the reference voltage generated by the 431 internally. So I got some quality components from DigiKey to see if that makes any difference whatsoever. So the first thing I want to do a quick comparison of that voltage that goes into the 431 on those 3 power supplies. Again, this one is factory. You can see it has the brown Nichicon capacitors. This one is the one that we repaired on camera, and this one is another one which I repaired off camera. It's not part of a video, but basically had exactly the same fault of this one, besides the broken capacitors. So I got my multimeter connected to the input pin of the 431 of these factory power supply. Let's turn it on and see what it reads. 3, 2, 1, go. And it's reading exactly 2.495 volts. This is the power supply we've been repairing on this video, so let's test this out in 3, 2, 1, go. And we have 2.484, which is, again, it should be 2.495. But let's take note of that and let's move to the next one. And this is the third power supply that I've repaired, exactly the same fault to the other one, drifting only 23 millivolts. Let's see what it reads at the TL431, 3, 2, 1, go. Right, and this is reading 2.481, so it's even worse if this is worse, or if that's a worse and better. But it's even further away the reference that I'm expecting. So now I start thinking that I'm definitely chasing ghosts. But again, I purchased those components. Let me show you what I want to do, then we'll replace them anyways. And if it doesn't change anything, happy days, we hopefully learn something from this. So what I'm going to do next, I'm going to replace those 4 precision resistors. Those are 1% resistors, and they're definitely part of the feedback circuit. As I said before, the feedback circuit is just a voltage divider which is designed to produce a specific voltage going to the 431 when a specific voltage is found in the outputs. Now, this trimmer at the top is the adjustment for the 5 volts, and these trimmers here, they can be purchased exactly as you want them. They're like in fixed values. I don't know exactly this one, but this could be a 10 kilo ohms or 100 kilo ohms, that kind of stuff. So I haven't got schematics for this power supply, but I'm assuming that to get exactly the voltage required for the 431 to deliver 5 volts at the output, they just added a couple of resistors before and after the potentiometer so that eventually you get what you want. And indeed, I can see that connected to this leg here, you can find this resistor here, and connected to the other leg here, you can find this resistor here. The other 2 resistors are for the other potentiometer, which is the 15 volts adjustment. So maybe I'm wasting my time, probably I'm wasting my time, but I've got those resistors anyways, so I'm gonna replace them and see if by any chance that changes anything. At the same time, I'm going to replace the 431, but before I do that, I'd like to set up a 431 on a breadboard and do a little test to just confirm the internal voltage, reference voltage of the replacement 431. What I'd like to do next is to get the 431s I've got from DigiKey and try to measure the internal reference voltage. I've got this little breadboard, and DJ Marek 78, my power supply guru, thank you DJ Marek, made a little schematics for me, which I'm putting on screen right now. And that allows me to measure the internal reference voltage. And by changing this little trimmer, rotating this little trimmer here, I can change the current that flows through the 431. So I can see whether there's any variation depending on the current flowing. So I have a more like a real world situation. I can get the extremes of the reference voltage. I've got 5 volts coming in through the power supply. It's disconnected right now. I'm gonna measure a number of 431s just out of curiosity and see what is the reference voltage. Then we'll select one, a random one. We'll install it into the power supply, and I'm curious whether at that point what we measure here on the breadboard is gonna be what we measure on the power supply when the power supply is running. So let me feed 5 volts into the 431. And I'm measuring 2.498, which is not far away from the 2.495, which is measured in the data sheet, which has tolerance, of course, if you look at the data sheet. So let's now go through the extremes of the current. And this is, I think, is a 25 turns potentiometer, so it will take a while to get to those extremes, but you should see me turning this. So I'm turning now quite fast. 496, okay, so this is now clicking, so it's one extreme, 2.488, and if I'm going the other way around, what I can see is that it quickly goes to that like middle range. So I'm now back to 2.497, it stays at 2.49798 for a while, and I'm spinning until, that's the other range. It just climbs to a slightly different number, 2.504. So we're talking about 15-20 millivolts of a difference, but there is like a plateau, if I'm saying that right, which is 2.498, let's put it that way. I mean, you can spin it in this direction or the other direction, and it never changes. It stays at 2.498 most of the time. So what I'm going to do, let's select this one, it's totally fine. I'm wondering whether when this 431 is in the power supply, will it read 2.498 or will it read one of the 2 extremes, or will it read something completely different? At the point, I don't know. And again, this is mostly an overthinking exercise and completely out of curiosity. I'll save you the hassle of watching me going through 7 different 431s. I've done this already by myself, and yes, there are some differences. These are the one extreme, the other extreme, and the like plateau in the middle. So let's ignore the extreme for the time being. I can see that there's something which is like 2.501, and there's another one which is 2.488. So there is a little difference, and again, I think the data sheet is saying this is going to be totally fine. I'm just curious to see whether this one, which is the 2.498, which is the one it's running right now, is the first one I tested, that's the one we're going to use, is going to read 2.498 in the power supply when the power supply is running. So let me swap it again, and then we'll take another reading and we'll check that number. Alright, the 431 is back on the PCB. I have a small load connected as before. I don't have the housing, so obviously I can't run this for too long, but it should be enough just to get reading. Will it be the same voltage that we were reading before, which was 2.498 on that middle range? Well, let's test it and see what happens. 3, 2, 1, go. 2.493, so it's 5 millivolts off that kind of middle range, but it's definitely within that range. So it looks like it's fine. I'll switch it off. And probably the differences I was reading between different power supplies is just different 431s with just slightly different reference voltage. I thought that the reference voltage was exactly 2.495, but it wasn't. It is not the case. Let's also check how much the reference voltage changes when I'm changing the voltage output of this power supply. Power on now. So we're reading what we were reading before, it's 94 instead of 93, and if I'm going to the one extreme, it's still 2.494. If I'm going to the other extreme, it's 2.495, so it doesn't change as much as we've seen with some other power supplies. It's only 1 millivolt, which is absolutely nothing. So what I'm going to do now, I'm going to reinstall this into its housing and I'll test it again, because I don't want to do anything else to this power supply before I'm testing it again. I'm confirming whether the drifting, that 48 millivolts drift, is still there or not. Because if I do something else and then it gets better, we don't know what it was. So I'll test it again, and then maybe if it's still doing it, then we'll swap those resistors I mentioned before. I've now tested this power supply for about 24 hours, and I was pretty happy this morning when I came to my workshop and I checked the drift, and it was only 20 millivolts compared to the 48 millivolts it had before. So I thought, oh yes, so we have some kind of results here. Then I realized it was much cooler this morning than it has been for the past few weeks. There's some cold air coming from the north. It's September right now, and a few weeks ago when I did these tests, it was still August, it was much warmer. So I thought, what if the room temperature is actually changing this result? So I turned on the heating, and over a few hours the voltage dropped an extra 10 millivolts for a total of 30 millivolts. Now I think this is telling us a couple of things. The first thing is that maybe we have an improvement, as this used to drift 48 millivolts and now it's only 30 millivolts. The other thing is probably all these tests are completely pointless because if the room temperature has a role into the equation, well, I didn't really record the previous test, and who knows, maybe all these tests that I've been doing, the difference between the tests was just the room temperature. I do not know. I think what this is telling us is that this is totally fine, and what we're seeing here is minor changes, mostly due to room temperature and maybe due to some minor tolerance with these older components. But maybe replacing the 431 has actually improved a little bit, because again, now we're reading 30 millivolts, who knows. Now, I understand that this is probably completely pointless. I'm not going to replace those resistors, mostly because I ordered them, I have them. I'm curious to see whether there's any difference whatsoever, but I'm totally aware that the next test probably won't have much sense because I can't control the temperature of this room, at least to some degree. But anyways, let me swap those resistors anyways. I'm curious to see what happens tomorrow when I'm testing it. Let's double check that all the voltages are there and also that the regulation of those voltages is working. I'm monitoring 5 volts, 3, 2, 1, go. Got 5.2 and it goes to 5.6 and down to 5.5, perfect. And let's check the 15 volts. 15 volts is also working and it goes up to 15.72 and down to 13.42, perfect. Let's double check that the minus 15 is there, I haven't touched it, and it's also there. So I'll test it again over like 24-48 hours and we'll see if there's going to be any difference whatsoever. I have tested this power supply for about 48 hours, and once again, I don't think my testing methodology is pretty good because I can't control the room temperature, so take this result with a pinch of salt, but It works. It now only drifts 12 millivolts like the factory one, unmodified factory one that I was taking as a reference. Now, did we fix this power supply? Well, compared to how I found it when we started this video, yes, absolutely. The voltage was dropping like before your eyes, and now as you can see, it's stuck at 5.222 and it doesn't go down. It will go down again 12 millivolts over several hours, but I don't think we fixed it after any further after we swapped that extra capacitor. That was the fault, and what I was observing that 48 millivolts drift was just age. Some of the components just changed their tolerance a little bit over time, and the output voltage was a bit more affected by temperature. That's it. But I do not feel that the initial 48 millivolts was the fault. It was just me wanted to, look into that a bit more and try to understand whether there was something that could be improved or not. After all, the purpose of my channels is not like just to fix things, but also to understand. And this is great because now I know that if I ever happen to have another one of these power supplies, and it might happen because it's some device that I'm working with, all I need to check is the capacitor, and if it really happens again, I can also take a look at those resistors, but within like 50 millivolts is probably going to be totally fine. But now at least I can return this power supply to its owner, and I feel a bit more confident that there's nothing wrong with it. I really enjoyed this video because I feel I've learned something, and I'm hoping that I was able to pass you this something as well. So I hope you enjoyed it as well. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my main channel if you like this kind of things. Don't forget, I'm on Patreon, and there is a free tier on Patreon if you want to support me. If you don't want to join me on Patreon, which is very understandable, maybe you can buy me a coffee. The link is also down below in the description. If you don't want to buy me a coffee, which is also very understandable, you visit here, maybe a like, a comment, a subscription, that would be appreciated. But anyways, I appreciate your time here anyways. The power supply has been on for a few minutes, it's still reading basically exactly the same voltage. So that's it for today. I hope you enjoyed this video, thank you for watching, and I hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye. Bye bye.